India is one of the fastest growing economies of the world. Indian cities are expanding fast with matching infrastructure and civic amenities. But the rosy picture faces a major challenge. A large chunk of domestic sewage and wastewater is disposed untreated due to insufficiency of treatment plants. Huge operational expenses and irregular power supply are major constraints in installation of conventional sewage treatment plants. But now a low-cost and environment-friendly solution is at hand to transform the scenario. It is Phytore Technology. It's a unique process developed by the CSIR, National Environmental Engineering Research Institute, Nagpur, that is based on natural treatment methods such as filtration, sedimentation, plants and microbial action. Technically called Phytore swab, that is scientific wetland and active biodegradation. The system primarily depends on a variety of plants normally found in natural wetlands with filtration and treatment capabilities.
The technology of Phytoedit, when it was developed, it was actually meant to solve the problem of sewage treatment, which is one of the biggest problem in our country. We are still not treating more than 70% of the sewage which we generate in cities. And major issue of sewage is that when it flows, it spoils our ponds, rivers, and nearby ecosystems, and anything else that which comes in water bodies. So the whole idea of developing this technology was that India, which does not have enough power to run sewage treatment plants, can we use nature to achieve the same objective? And in this case, we have been able to achieve this without using any chemical, any electricity power. It entirely works on the nature-based principle.
In a typical Phytore treatment plant, wastewater is first passed through a screen chamber where solid waste is separated by using bar screens. Oil and fat is also removed, then pumped into a sedimentation tank using a sump. Collection and sedimentation system allows suspended solids to settle down in the tank, and simultaneous removal of biological oxygen demand, that is BOD, by more than 50%. Now, wastewater is passed through swab bed that has 3 distinct zones. Inlet zone may have crushed bricks, gravels, stones of different sizes, thermocol, coir, etc. as filter media. In the treatment zone, in addition to filter media, wastewater is exposed to root zones of plants that uptake nitrates and phosphates from wastewater and also cause enzymatic degradation of pollutants. Treated wastewater can be used in horticultural or farm irrigation, fountains or backflushing in toilets, etc. Treatment efficiency of Phytore system is excellent with removal of total suspended solids, biological oxygen demand, chemical oxygen demand, total nitrogen, phosphate and fecal coliform. Niri has patented this novel technology and licensed to several stakeholders for field applications. Small to big and large phytorid units are coming up fast in many parts of the country. Recently, Niri established the largest phytorid plant in Delhi with a huge capacity of 30 lakh litre per day. The plant is doing a great environmental service to capital city.
Initially, number of plants were 21,000 and now their numbers have increased and just crossing 1 lakh. So that is the beauty of this technology. So filter media will take care of organic pollution and plants were taking care of the nutrient. The technology has successfully implemented it more than 200 places across the country, and it has been approved by Government of India like Ministry of Housing and Urban Affairs, Ministry of Drinking Water and Sanitation, and recently the technology has been published under the Swachh Bharat Mission and Swachh Bharat Mission Manual, that's liquid and solid waste management.
Phytorid technology can even be applied to flowing nala full of filth and wastewater. Technically termed as restoration of nala with ecological units, RENEW. The technology was a bit modified by putting screens in the flowway instead of separate chambers, and plants were placed in floating blocks. The novel manner of putting plants at work facilitated the treatment process. Plant blocks were regularly cleaned by taking them out to maintain their activity level.
The treated water is being used within the Niri campuses for gardening and floriculture purposes. We have been doing research on the technology since 6 months. This is operational, and we have been getting good results. The treatment efficiency is around 80 to 90%. We are hoping that the technology will be commercially available very soon.
Phytorid treatment plants are self-sustainable and environmentally benign due to low maintenance and operational cost, minimum electricity requirement, smaller footprints, recycling and reuse of water, no foul odor and no mosquito nuisance. No wonder Phytorid technology is making waves across the country. A new era of safe and sound disposal of water waste has begun. Phytorid swap technology is most sustainable and economical as compared to existing sewage treatment technologies based on life cycle cost analysis in terms of capital, power requirement, chemical, manpower and operation, and maintenance cost.
On our part, I want to commit that in the 25th year of our existence, climate action will be taken as a mission mode by Mumbai First, starting with the conference we are organizing today. We will work hand in hand with the government, industry and citizens to achieve this.
That's something which is very critical for a city like Mumbai and Mumbai Metropolitan Region, because our city planning is something which we have done very well. But when it comes to planning based on the environmental parameters and the climate change parameters, we haven't actually done much of thinking in that.
If we manage to plan ahead, if we manage to undertake early adaptation, this can help protecting people, assets, and nature.
So we are leaving the safe zone and we are unprepared, right? Having said that, understanding the risk, okay, and we have now many models to understand the risk specifically to the cities, and getting prepared by incorporating in your decision making as well as in your designs and planning.
Brown, there's more than 50% people of this ward are living in slums. So that's one big challenge, that how to provide housing for all in this scenario. And housing, with it comes the challenge of enhancing infrastructure. Now, infrastructure is not just roads, but it is water and sewage facilities and sanitation facilities.
All the measures that they've conceived are also implemented, and the impact on the Dutch economy is pretty strong.
Also, the awareness at local levels still need to be enhanced. The knowledge needs to be increased on how to actually adapt in the long term.
We are actively working on signing an MOU between the two countries, because again, what we want to have is a more fruitful engagement. There has to be, in our vision, multi-being.
Risk management clearly indicates that we should be prepared to ensure that the worst does not affect human life and in fact all life on this planet.
Also around the world from an economics perspective and on the economics of adaptation in the context of sea level rise for coastal cities.
Intrinsically be adopted and be taken care of. Only then we can have a complete decision support system for addressing these issues.
And in each country, we try to see how we can cooperate to strengthen the implementation of the Paris Agreement.
In Mumbai, not a single road is ever closed for any infrastructure work. This doesn't happen anywhere.
That's also replicated in many cities around new forms of densification.
But as if the climate emergency is not enough, now in Italy we have a coronavirus emergency.
There are many places which do not have 24 hours water supply, like Mumbai has.
Roads which are being planned are having a grid system on the lines of Manhattan. There also the stormwater drains which are being planned on in such a way that the flooding can be avoided.
We have our own, we try to self-sustainable. Like we have NDRF, we have National Disaster Response Force, 3 teams available in Mumbai. But we thought 3 teams are not sufficient for Mumbai. And therefore we have our own security force. We have imparted them a specialized training in CBRN and CSSR.
Similarly, we have permeable resins around the trees so that it allows the tree to breathe.
Separate planning for water and say, different planning for sewerage and the third planning for stormwater and overall planning for the city requires integration.
The first being ecosystems and the second being communities.
Vector-related diseases, that is malaria and dengue, we need to have people's participation here.
Bust. In climate change as well as health, prevention can conserve our wealth. Prevention is much better than cure, so learn it now or then endure the endless pain and aggravation of the heavy cost of adaptation. Thank you.
This landmark event on climate crisis, Action for Tropical Coastal Cities, was planned as part of the Silver Jubilee celebrations of Mumbai First.
Ladies and gentlemen, we value your participation and thank you for coming. Thank you, panelists, for being here.
Good afternoon, ladies and gentlemen, to the webinar on championing smart and sustainable water use and wastewater management in MMR. I am Dr. Neville Mehta, the CEO of Mumbai First, and I'm so happy to have you all with us this afternoon. You have already seen the introduction of NEERI and Mumbai First, so I will not spend much time on it. But before I call on Mr. Nandan Maluste, our trustee of Mumbai First, to welcome you all, I will go straight to the format of today's webinar. As you know, it's a 3-day webinar. This is the second day, and we are having 5 panelists on board. When they give their presentation, we will then follow with a panel discussion. Please send your questions on the question answer chat, and we will try and answer as many questions as we can, followed by a vote of thanks. A little ground rules for the presenters. The presentation will be operated by the back office team. You are requested not to press the record button. Also, keep your chat box open so that the back office can give you a cue. And for the participants, you will have in your chat box the feedback form. We would request each one of you to please fill up this feedback form and send it to us so that we can keep in touch with you and also get your feedback. Let me call upon Mr. Nandan to give us a welcome address. But before that, let me very briefly introduce Mr. Maluste. Mr. Maluste is the honorary trustee of Mumbai First and has been so since the 1990s. Over 4 decades, he has had a varied career in India, the United Kingdom, and the Gulf as a public accountant, management consultant, journalist, advertising executive, entrepreneur, angel investor, board member of companies, trusts, and societies, researcher and consultant in government, investment, and private banker. Apart from speaking regularly at professional, industry, and academic events, Nandan has presented at the Parliament's Standing Committee on Finance. He has been published in the R&D Management, Oxford, World Affairs, New Delhi, Business India, and many more. He is a graduate of Manchester Business School, England, and a fellow of the Institute of Chartered Accountants in England and Wales. He is also an alumnus of the Indian Institute of Technology, Bombay, and the Cathedral and John Cannon School. May I request Mr. Maluste to give his welcome address.
Thank you, Neville, and good afternoon, friends. Thank you all for being here. As Neville said, it's the second day of a 3-afternoon program. Yesterday, after an overview by Dr. Rakesh Kumar, the Executive Director of CSIR-NEERI, we focused upon sewage water and how to deal with that. And of course, that's a crucial issue in metropolises such as the Mumbai Metropolitan Region. Just to remind you, the Mumbai Metropolitan Region actually encompasses about 6,300 square kilometers and houses about a quarter of the population of Maharashtra, India's second largest state by population. Amazingly, the Mumbai Metropolitan Region also comprises about 80% of the GDP of Maharashtra. So today's topic becomes also very important. Today's topic is dealing with industrial waste. And I'd like to invite Ms. Meesha Tandon to take over and moderate the proceedings hereafter. Ms. Tandon is an architect planner who specializes in water resource management. She's done a variety of very interesting things, but today she works as an independent consultant and advisor, educational entrepreneur in climate change, and as a member of the United Nations Habitat Planners for Climate Change Action working groups. Right, Ms. Tandon, would you like to take over? Thank you.
Thank you so much, Mr. Malukse. And we have a very interesting and esteemed panel today. I would quickly introduce the panel and invite them to join us, and then we'll go one by one with the presentations, and I'll keep on introducing the presenters. So on the panel, we have Mr. J.John, who's Director, Common Effluent Treatment Plant, Thane, Belapur, along with his colleague, Mr. S.R. Iyer. Welcome, sirs. We also have Dr. Ritesh Vijay, who's Senior Principal Scientist, CSIR-NEERI. We have Mr. Lubaina Rangwala, who's Senior Manager at WRI, and myself. And so now we'll start with the presentations. The first presentation is going to be on current performance scenario and future plans for CETP by Mr. J.John and Mr. S.R. Iyer. I'll give a quick introduction to Mr. John. He is the Director of Board of CETP Association, as I mentioned. He's also the Technical Director of TPC Waste Management Association for Hazardous Waste Disposal and Wealth from E-Waste. He has a background in chemical engineering, business management, industrial safety, and industrial pollution control. He has more than 35 years of experience, which includes his stint at Tata Enterprises. He is he is also the corporate head DEHS, Environment, Health and Safety at, and promotes trade effluent treatment plants across India. So welcome, Mr. John and Mr. Iyer, over to you.
Hello, thank you, ma'am. Can you hear me?
Yes, sir.
Yes, sir. Yeah, thank you. And good afternoon to all my learned friends. The presentation I would be doing now, as she mentioned, it will be on the current performance scenario and the future plans for CETP. That's a common effluent treatment plant. Can I have the next slide? See, as you all know, the common effluent treatment plant concept came to India in 1983 with the first CETP setup in Pali at Rajasthan. And then the second one was set up in GD Metla, that's at Hyderabad. So these were the two ones that were set up earlier. And then by 1991, the government came out with the incentivizing the common effluent treatment plant. And that kicked off any further common effluent treatment plants coming up in various parts of India. So now to talk about the common effluent treatment plant of Thane Creek area. Those days, the Thane Belapur industrial belt was one of the biggest industrial zones of Asia. And it was comprising of large-scale industries, medium-scale industries, and also small-scale industries. And the CETP option was brought in by the Thane Belapur Industrial Association in 1994. And the main purpose was to support the small-scale industries. And accordingly, a 12 MLD capacity plant was commissioned in 1997. And thereafter, there was a capacity augmentation done to 15 ml, additional 15 MLD in 2006. So thus bringing the CETP, it eliminated the techno-economic constraint that the small scale industries were facing. So they were given an option to treat their effluent and also to discharge it into deep sea. So considering the other medium scale industries and the large scale industries, although they could treat the effluent to the required standard, but they had no option how to reach it to the mid sea. So they needed a carrying capacity, and thus they were all joined with the common effluent treatment plant, and their treated effluent also joined to the common effluent treatment plant. So this CETP registered under the Companies Act. Can I have the next slide? See, this is the belt of Thana Belapur Industrial Area, which is around 12 kilometers in length and a depth of 2 kilometers. And it is promoted by the Maharashtra Industrial Development Corporation. Next, please. If we look at the slides, we have categorized the industries based upon the category that is being given by SPCB, that is State Pollution Control Board. In the red category, we have they have 22% of the share, and then the next would be the orange category. They have almost 3% of the total share, and then we have all the green categories, the remaining. Next slide. So we will not touch upon the current performance scenario of CETP. See, there are certain success factors behind this CETP. The number one being that it is professionally managed by a board of directors, and all of them are expert in their own field, and especially they have the technical and managerial expertise to control and also to administer. And the CETP have been always proactive in enhancing the capacity buildup. And to understand how are we moving, there is periodic performance evaluation being done by a third party. And CETP is always in forefront to adopt the best available technology for when we come to upgradation and integrated management systems. This CETP is running on the basis of a system-based and scientifically promoted operation system. Can I have the next one? See, as for the operation of the CETP, we have well qualified and trained manpower, and the control system for the quality is multi-layered. And we also have an ongoing interaction with the member industries to resolve the influent issues. As you know, this is a cooperative approach that is being carried out for the functioning of the CETP. And we also handhold our members for upgrading their treatment system whenever they have any problems, and also to choose the right treatment options. And the CETP is also involved in various environmental initiatives. So with all these success factors, we have the milestone of success. We have the CETP this CETP has won the Vasundhara Award instituted by the State Pollution Control Board, first in the year 2015 and again in the year 2018. Next slide. Now coming to the controls and compliances, this CETP is running on the principle of mutuality. That is, all the user members are also part of this board, part of this administration. And the board of directors are chosen by election during the annual general body meeting. So there is a tripartite agreement between the member, CETP and MIDC. Now for the SSI, as you know, this was mainly built for the SSI units. So the SSI units are supposed to do the primary treatment, and then they can discharge the effluent. From the CETP end, there is periodic vigilant sampling done from the SSIs. Now for SSIs and LSIs, they are supposed to be doing the primary and secondary treatment and bringing the effluent to the required stipulated standards based on the consent order issued to them by the SPCB. The monitoring is, we sample almost 3 times in a month. And besides all this, we have surprise sampling done in the night, as well as when they least expect. Coming to technology and process, the treatment option that is carrying in this CETP is the conventional treatment system with the pre-primary, primary, secondary, and a part of tertiary treatment. And the effluent is received through a network of dedicated underground drainage pipeline well laid out throughout this Maharashtra Industrial Development Corporation area. And the final discharge is through one pipeline, which is underground, and it joins to the deep sea through the creek. Now for the sludge disposal, we are also a part of the Trans-Thane Creek Waste Management Association. Some of the directors are common in both. So that facility is well being used for disposal of the sludge in a scientific and environmental friendly manner. Next slide. Yeah, this is the flow diagram, a single diagram of how it happens. The effluent moves from the pre-primary stage to the primary, and where the coagulation and flocculation happens. And then after that, it goes into the clariflocculator where the sludge is removed, the primary sludge. And after the removal of the primary sludge, the supernatant goes for biological oxidation reaction into the biobasins, where microbes are pre-developed and acclimatized to the effluent of CETP. Then it flows into the secondary clarifier, and from the clarifier, the treated effluent goes into the V-notch, from where it joins the pipeline for disposal. Next slide. This is the network of the pipeline that is laid out all across the MIDC for carrying effluent. Now coming to our stage, the stage 1 is, as I mentioned, it is a pre-primary treatment stage where equalization and utilization is done. So there we have, and also the effluent is kept pre-primarily aerobic, wherein the zeta potential of the water is changed so that the coagulation rate and the flocculation rate increases, thereby the entire sludge gets separated. Next. Coming to the clariflocculation, there the sludge gets separated, and we have around 20 to 30% reduction happening in COD and BOD. The main thing that happens over here is the reduction in suspended solid. That is about 80 to 85% gets removed there. Then the supernatant liquid moves into the secondary treatment system. And here it is, you must be seeing on the photograph. Can you scan the photograph? When the slide move forward? One more. One more. Yeah, that's it. So this is no, please come back to the older slide. Please come back to the old slide. No, you are going further. Yeah, that's it. No, next one. No, don't go upward, come downward, please. Yeah, you have skipped one. Okay. So now, one slide earlier one. You are jumping, madam. Okay, I will continue with that. Just keep that slide there. So in the aerobic system, we have about 80 to 85% reduction in COD and about 90 to 95% reduction in the BOD. And this is where the biological oxidation happening with the pre-cultured microbes. And in fact, this is a facultative aerobic system where down it is anaerobic and top it is aerobic. Now we have provided mixer aerators in this aeration tank so that the water depth is churned out and brought on top for having aeration. Then the clear effluent flows into a clarifier, and from this clarifier, the biological sludge that is called the activated sludge is removed, and the supernatant liquid, which is treated to the required standard, moves to the V-notch. Next slide, please. Next slide. Yeah, so this is how we dewater the sludge. The sludge that is removed from the primary stage as well as from the secondary stage has to be demoisturized, dewatered. So we are using the modern technology of the volute filters, monobelt, and also we are supported with the solid ball decanters. Next slide. Next slide. For quality control, we have the real-time online monitoring that is for both for the inlet of the influent as well as for the outlet of the effluent. And data from these monitors are linked to the site of the State Pollution Control Board and also to the Central Pollution Control Board. So they are the watchdog people. They're always monitoring this. So before this online system, we had online TOC, that is total organic carbon meter, which is again connected to the treated effluent. And this is a correlation between the COD and the TOC data. So the reliability factor is little low in TOC, and that is the reason why we moved on to the real-time monitoring system. Next slide. Next slide. So we have certain areas where we have gone for automation. For all to know, for the operator to be vigilant, we have the alarm system given to the critical equipments and also actuator control valves based upon the timing. And we have a mimics panel where we can see the entire treatment system happening and the flow. Next slide. This is the environmental lab. We have well equipped to meet the requirements of in-house. And also the main criteria here is analyzing the samples, that is the vigilant samples, which is being brought from industries, because there is always a confusion that happens with the results. So we have to be very precise and accurate in getting the results, and our lab is well equipped. We also have a microbiology lab where we'll be carrying out biological oxidation experiments, and also to have the BOD analysis done. We have the automation for the pH indicator, the dissolved oxygen indicator, and the flow indications. Next. So we also promote environmental awareness among the school students and college students. Many of the college students, especially those who are doing environmental science as their subject, they visit CETP for their internship and also to have a feeling about the technical aspect about how a wastewater treatment is happening. Next slide. Now, these are the present challenges that we face in the day-to-day affairs. See, the nature of effluent that we receive is promiscuous in nature because the type of industries are different in this belt, and the type of effluent that is being generated at every industries at various parts of the time throughout the day also differs based upon the time cycle. And this effluent also carries sometimes the entrapped gases because it is passing through the common pipeline, and there's a probability of further reaction happening between the waste streams inside the pipe. So these entrapped gases also have to be eliminated in the pre-primary stage. We also face, our system also has a vulnerability for shock load, for both volume as well as for strength. The main factor that we face is the increasing energy cost, because almost 55% of our operational cost is for energy. It's a big chunk of money that goes towards energy. And this energy cost, as you all know, never goes down. It keeps on increasing every year. So this is a real challenge for us. And another is the discharge standards stipulated by for the statutory authorities are becoming stringent day by day. So we have to augment ourselves and keep improving our treatment system to meet the stringent standards. We also have the attack from the impact of natural hazards. Especially during rainy season, there is a chance of water flooding because, as you know, the flow of the effluent from the industries through the pipeline is by gravitational flow. So naturally, the receiving end of most of the CETPs are low-lying, and this is being faced by most of the CETPs. And whenever we go for an affordable treatment option, what we face is that option is carbon incentive. So from the climate change aspect, we need to rethink about it. And another problem is our insufficient time, the pre-primary stage, to keep the effluent pre-aerobic. So keeping these challenges forward, we have the future plans for this CETP. And when we are planning for the future, we are keeping the sustainable development in our mind, and also about the water as a precious commodity. See, we are considering water not only as a social issue, but it is also going to be a business issue. And that's why it is said that the next world war will be for water. We also understand that water is no more a disposable item, because the present per capita availability of water in India is 20% of what it was in 1947. And we also know that the water resources are not infinite. So by 2030, it is said the water demand will be 40% more than the supply that will be available. Whenever we choose for the wastewater treatment option, we always keep the climate change in aspect, thus contributing to global warming and also to the Kyoto Protocol. Next. Next slide. Next slide. Next slide. When we have the sustainable development in our minds, we always think about the triple bottom line aspects. As you all know, it is the social, environment, and economic. In other parlance, it is said to be the 3 Ps, which is the people, profit, and planet. So all our attempts are focused on the 3 Rs, that is reduce, reuse, and recycle. Of course, there is a 4th one which is still not prominent, that is recharge, recharging back into the water table of the earth. So in this plan, we wanted to have the maximum water that whether we can go for reuse and recycle. Can I have the slides advanced? One more. Yeah, we did some trial runs in the reverse osmosis plant. We built a plant, a pilot plant with 100 cubic meters per day, and we had been successful in getting water that can be recycled and reused. But the factor is, there's a cost factor to that. And also, who will take this recycled water? Because it's a huge quantity of 27 MLD. At the same time, we also need a distribution infrastructure to reach back to the user members. Another hurdle that we face is the clearance from the statutory authorities, especially from the water distribution authorities. So we need to have some system wherein it will be made mandatory that industries or whoever generates effluent should take back a percentage of the treated effluent as well. Next slide. We are also working on reducing the carbon footprint in our biological oxidation. That is why we are trying to change the facultative aerobic system into purely aerobic so that methane generation does not happen. It is all to water and carbon dioxide. As you know, the potential of methane is high when it comes to climate change. We did some experiments with changing into membrane bioreactor, because membrane bioreactor needs less volume of the effluent for aeration system. We did a pilot plant and it has been successful. Go back, go. As I mentioned to you earlier, the standards have become stringent, and now what the present BOD level for discharge is 100 milligrams per liter. And we have been now asked to move towards 30 milligrams per liter. So working on our effluent proactively, we did trials with the membrane bioreactor, which I already mentioned to you. And we have been successful in getting less than 30 milligrams per liter. Now it is only scaling up to our requirement. But again, here the biggest hurdle is the huge capex that will be required to convert from the conventional biological oxidation system to membrane bioreactor, and also the operational cost. To reduce the strength of the effluent, because there will be certain streams being generated by our members which are high in the load but low in volume. And once they join the mainstream, we'll have to treat the entire volume of the effluent that is coming. So we are planning to collect all those streams separately from our members and bring it to our CETP, bring it to this CETP and treat it separately which will be amenable to our existing biological system. So to go with conventional method of doing the oxidation, we do not have enough land available with us, so we cannot think of it. So the best available technology we are anchored on is electrocoagulation that can increase the coagulation and flocculation rate so that we don't need the pre-primary system, such a huge one. And also, we are now, for the next one would be the ozonation or catalytic oxidation. That will be as a precursor to the biological oxidation, wherein the refractive CODs are broken down to amenable reactive CODs that can be further undergone treatment by the existing biological system. As I mentioned, the slide please move once more, one more up. Yeah. I mentioned to you that energy is a big cost. It's almost 55% of our treatment cost. So we need to move from the conventional energy into non-conventional energy. So we are thinking of harnessing solar or wind energy for our operation. So accordingly, we put up a solar system, and we have found that it is successful, but it's a low plant. So we need to now think about making it a bigger plant so that our requirement is almost 1 megawatt. And so if we are able to harness solar or wind energy for our operation to an extent of 1 megawatt, number one will be the reduction in the energy cost that we are incurring today. Number two will be that will bring down of the carbon footprint from the baseline of our carbon generation. And then we also plan to have the LEED certification of this CETP. So that will make us green. Next slide. Now coming to the other future plans that we have in our mind, we are planning to put up an innovation center so that we can continue to carry out our treatability studies and technology assessment within ourselves. We are planning to upgrade our laboratory so that the laboratory can achieve NABL accreditation and also approval from the Ministry of Environment, Forest and Climate Change. We are taken up with the Development Authority to relay or replace the old pipeline that is of the network that is carrying influent into this CETP. We are also working on replacing our critical equipments with the latest version equipments. We would like to do for a benchmarking with the best available setup of wherein we will have some common indices selected, and accordingly we can have benchmark of the CETPs. We also plan to have a full cost assessment of this CETP. So that will help us in tracking our sustainability under the triple bottom line. We are also planning for reporting and communication system so that the world need to know what are the good activities being done here. One of the options that we are thinking of is the corporate sustainability report based on the GRI standards. So if not for all the standards, at least the standard of environment, that is GRI 300, we would like to adopt and have a communication done in that regard. Next slide. We are thinking of approaching the government agencies for getting subsidy when we want to adopt the best available technology so that it becomes economically affordable. We would like to promote our user members for eco-labeling of their products and also for them to become responsible care signatory. The intention is to bring in a consciousness in them in the aspect of reduce, reuse and recycle, and also on the other environment phenomena. And we would like to provide support to our members to carry out a life cycle assessment of their products so that this environmental aspect also get inculcated in this LCA study. We would like to incentivize those members who reduce usage of toxic chemicals in their process so that they can think of changing their process system, thereby the toxic effluent generation is reduced. we would love to promote and handle all our members for a wastewater management, because instead of treating the effluent at the end of the pipeline, the best methodology and the best option would be to have it at the source of origin. And our members are the source of origin. So we would like to handhold them to carry out that. The another option is to do a water audit being done by all our members, so that they prepare a water budgeting and also a water balance, so that it helps them as to know where do they stand. And through the related agencies of, especially government agencies, we would love to work on having an eco industry. So that's all from our end. Thank you. Thank you to all of you for having patiently listened to our presentation.
Thank you so much, Mr. John and Mr. Iyer. That was a really interesting presentation. I mean, lockdown has shown us how important it is to address the issue of industrial pollution. And it's really interesting to know that you have provisions for real-time monitoring of outflows. You are also looking at reducing the climate footprint through methane reduction, and also considering aspects wherein you can introduce renewable energy to reduce the load on the grid and the carbon emissions as well. So I don't think I'll be wrong in saying that it is one of the best role models in terms of CETPs that I've come across till date. So thank you very much for that very interesting presentation. And now I'll move on to the next speaker. Our next speaker is Dr. Ritesh Vijay. He is going to talk about sustainable liquid waste management, urban India context. Now, I'll just quickly introduce Dr. Vijay. He is a senior principal scientist and head at Center for Strategic Management at CSIR-NEERI. He has been he has over 20 years of experience in strategic urban management, and he specializes in decentralized sewage treatment. He has had more than 70 publications to his credit, and has participated in several national and international conferences. So I invite you, Dr. Ritesh Vijay, to please take over. Welcome.
Thank you, Ms. Tandon. And yeah, so I think first of all, I just congratulate the organizing member of conducting this webinar, and that to be the most important region, I should say, of India. That's the Mumbai Metropolitan Region. And the context itself is challenging, but it's doable. That's championing smart and sustainable water use and wastewater management in MMR. So let's see how we can think. And before I start, technically, I think I slightly introduce about CSIR. That's the Council of Scientific and Industrial Research, National Environmental Engineering Research Institute, comes under Department of Science and Technology. It's established in 1958, and the name was Central Public Health Engineering Research Institute, and then renamed by the and then Prime Minister late Srimati Indira Gandhi in 1974. That's the National Environmental Engineering Research Institute. So we are working in all the field of environment, and we have our journal and research innovation centers at 5 different locations apart from the headquarters Nagpur, and that's Delhi, Mumbai, Kolkata, Chennai, and Hyderabad. Yeah, next please. So of course, the mission and vision of CSIR-NEERI, it's R&D in environmental science and engineering, and to provide assistance to industry, government, and nowadays I think we are providing our support to Honorable High Court, Supreme Court, and Honorable NGT cases. We are very fond and interacting with our collaborators, that may be academic and research institutions, on environmental science and engineering for mutual benefit. Next, please. Yeah, so these are some of the core strengths, whether we have air pollution, water, wastewater, biotechnology, cleaner technology, environmental impact and sustainability, environmental materials, sustainable urban management, and Center for Strategic Urban Management. So like NEERI has more than 10 in technologies, which is already available in the field. And yeah, next please. And in terms of, we talk about the water, and one more next, please. If we talk about in terms of water and wastewater, Niri has the water technology in terms of its electro defluoridation and NIRJAR. And as far as the sewage and wastewater concern, the Pali, my last previous speaker, Dr. John, was talking about the Bali CETP, and its a design and concept was given by CSIR-NEERI in 1990. If we talk about wastewater, so like Niri has technology for Phytoedit, and I think before starting of today's webinar, I think you've seen the glimpses of Phytore technology, and it's widespread. From very recent, Niri has introduced one more technology, that's a restoration of Nala with ecological units, that we will see how best we can manage the water and wastewater issues in urban contexts. Next, please. Yeah, CSIR-NEERI has recently started the Center for Strategic Urban Management, because I believe unless until we treat and we solve the sanitation and environmental issue of any urban city, we won't make our city smart and smarter. So the need of Center for Strategic Urban Management is there, yeah, and we are working in all the contexts of urban management, whether it's networking of city, whether it's resource mapping, whether it's nowadays the concept of facility mapping and infrastructure mapping. We are providing solutions for wastewater, urban wastewater, and urban flooding. Already the Bombay has great experience of flooding. And even if we talk about 2018, Vasai Virar, which is very much part of the Mumbai Metropolitan Region, and 2018, the flood was there up to 36 hours in Vasai Virar city. So that's the Center for Strategic Urban Management, is there to provide solution to urban and local bodies. And we are connected with Swachh Bharat Mission, both urban and Gramin. Next, please. Yeah, I think the whole theme is like how we can, I should say, put up the issues of water use and wastewater in MMR. So I think we should know some statistics about Mumbai Metropolitan Region. So if we talk about population, so like MMR has 17.76 million. And if you talk about its area, it's 4355 square kilometer. But if you compare the density per person, like if talk about Maharashtra and India, which is more or less similar, that's a 340 person per kilometer square. But if you talk about MMR, it's a 408 person in per square kilometer. So I should say we are highly dense region in India. Of course, like MMR is providing the contribution of 39 GDP, sorry, it's wrongly spelled. And if you talk about the number, this Mumbai Metropolitan Region has 8 municipal corporation, 9 municipal council, and more than 955 villages. So it's a huge area. And if you talk about its water use and wastewater management, I think we need to think critically and carefully. Yesterday, we have a very learned speaker, Dr. Majumdar, Dr. Sauli, who took and touched some of the part of water and wastewater and the planning of Greater Municipal Corporation of Mumbai about their sewage treatment plant. So I think these are the 8 municipal corporation and 9 municipal towns, and there are more 40 planning authorities. They are working at the level of micro level for different issues of Mumbai Metropolitan Region. Next, please. So coming, yeah, thank you. Yeah, so next, please. Yeah, if you talk about the water supply, so the Greater Mumbai itself required 3,330 MLD, that's a million liter per day. And if you talk about rest of the MMR, we require 2,119 MLD. So we are fortunate that we have surface water all around or inside the MMR region, but we are very unfortunate to not provide the solution for wastewater and sewage. Next, please. If we talk about reservoir and lakes, it's still in the Greater Mumbai, we have 6 very large, 37 medium, 49 small water bodies, and 80% of them have some issues of mesotrophic and eutrophic issue. We talk about any other cities of MMR, whether it's a Navi Mumbai or whether it's a Mira Bhander, whether it's a Bhiwandi Nijampur, or whether it's a Thane, we have plenty of water bodies and lakes, but if we talk about its water quality is not that good as it's required as per the surface water standard. And the impact of solid waste and sewage and wastewater, these water body is a big concern. Next, please. If we talk about wastewater generation, so Greater Mumbai itself generate 2,776 MLD of sewage. And if you talk about whole MMR region, that's touching around 4,000 MLD. So I think these are some of the challenges we need to understand in terms of its quantitative analysis, whether we have sufficient sewage treatment plant, and suppose we have sewerage network. And yesterday, Dr. Majumdar was talking about the shallow sewerage system. NEERI is providing solution for shallow sewerage system. And the beauty of that decentralized shallow sewerage system, we need not to deep and provide our sewer line more than 1 and 1.5 meter or 2 meter. So it will be easy to maintenance, and we can handle the manpower which are entering it's for maintenance and cleaning. Next, please. So this is, I'm talking about the sewage, but like we have industrial wastewater. And if you talk about total industrial wastewater, which are water-based industries and non-water-based industries, so we are generating more than 835 MLD of industrial wastewater. So my previous speaker talked about the common effluent treatment plant and individual effluent treatment plant. So these are the dire need to make water use more sustainable and practicable in MMR region. Next, please. Yeah, just these are some concern and common things in wastewater generation and treatment. If you talk about India, we are generating more than 66,000 MLD of wastewater, and that to be only class 1 and class 2 cities. And we have more than 5,000 cities which has population more than 1 lakh. If we talk about only Maharashtra, we are generating 7,000 MLD, but unfortunately we are treating only 30% treatment across country, and the treatment is vary from 3.4 to 90%. We are fortunate, like if you talk about Greater Mumbai, so we have good collection efficiency and we have 7 sewage treatment plant, but the level of treatment is need to be improved as per the recent guidelines by Honorable NGT in April 2019. But it's very difficult to achieve that BOD less than 10, suspended solid less than 20, and COD 50 milligram per liter. So we big challenge, but I am happy that MCGM engineer was talking. MCGM is quite open about the technology. So we need to opt and think the technology based on its sustainable concept and life cycle cost analysis. Next, please. Of course, we know all these waterborne diseases in India, like 70% diseases are through waterborne, and it's very difficult to manage and decomposition of organic waste. And we know how the Indian rivers, Indian water bodies, Indian creeks and oceans are getting polluted by discharging these sewage and wastewater. Like we have issues of odor, mosquito breeding, and bathing quality of river and beaches. It's a big challenge, whether we talk about SW1 to SW5, and the microbial and pathogenic microorganisms are also contaminating these water bodies. Next. Yeah, I think these are some like frequently asked questions. What kind of technology we need to link for, we need to think for, and when we construct sewage treatment plant, so it's a huge cost of its infrastructure. So whether we can think of its operation and maintenance, trained manpower. If we see as per Central Pollution Control Board, like most of the sewage treatment plant is not running because we don't have trained manpower. So we need to generate the green job and the manpower who are trained and who can handle. So it's a big opportunity for whole India. So we can create all such type of opportunities. And whether we can really sit and have some gossip and chit chat near sewage treatment plant, and whether we can use that water for its reuse and recycle. And aesthetic is also a big concern. And finally, can we use this water? Next, please. I think this is some general concept of conventional wastewater treatment, which requires so many pumps, so many chemicals, so many electromechanical parts, so many mechanical parts, and whose pipe diagram. So we require so many things to maintain and run that conventional sewage treatment plant. Next, please. If you see, these are the latest sewage treatment technology, whether it's ASP, that's activated sludge process, that's moving bed bioreactor, then sequential batch reactor, and safe bioreactor, that's SAFF. So these are the latest treatment technology we generally use in the city and urban context. Next, please. And like, as I told, which technology should be open and should be adoptable, I think we need to compare those technology based on, there are so many a number of factors, and that is the dire requirement of any technology which we are using. So that's required, it's a life cycle cost analysis, and that only teach and consider all the parameter, whether it's a capex, whether it's area requirement, whether it's energy requirement, whether it's skill manpower, whether it's operation maintenance. Next, please. And whether how best we are able to remove the treatment parameters, whether it's dissolved oxygen, biochemical oxygen demand, COD, suspended solid, ammonical nitrogen, and phosphate. Next, please. So I think now we are, and India has all sewage treatment plants which are basically centralized. And Government of India is now promoting and talking about the decentralized sewage treatment plant, not only the sewage treatment plant, now Government of India is talking about the decentralized sewerage system also. So can we think of some decentralized sewage treatment technology and plant? So I feel and I believe, whatever little experience I have, that constructed wetland has a big opportunity to consider as a decentralized sewage treatment plant. So there are a number of technologies are available for constructed wetland. So next, please. And CSIR-NEERI has developed one constructed wetland engineered technology, that's a Phytore Technology, and it's work on the phenomena of filter and plants, and filter will take care of the organic pollution, and plants are taking care of the nutrients. Next. Yeah, so this is the engineering schematic of this technology, where we require some source of wastewater and sewage. We need to make some sedimentation tank to allow that water for some time, and this patented technology of Phytoedit bed, which is basically a gravel and substrate, that's a filter media, and plant which take care of the entire organic and nutrient pollution. And finally is clear water tank, that water we can use for a number of reuse and recycle purposes. Next. I think these are the plant species, and CSIR-NEERI has worked and did research from last 15 years about the variety of plant species. So I think we are making the aesthetics so beautiful with the help of these plants, and at the same time these plants are taking care of the nutrient removal from the sewage. So these are some of the things which is commonly known is the Cana, Elephantia ear, and Cypress, and Typha. So these are generally used in constructed wetland. Next, please. So this is all about the Phytoedit technology, and the beauty of that Phytoedit technology, we are not using any soil and any sand in the treatment system, and treatment itself is taken care by the different size of stone, crushed stones and aggregates and plantation. And we provide these white vertical lines. These are the baffles which allow water to move and more contact of sewage with the bacteria and substrate. And the lower portion in the absence of oxygen work as an anaerobic, and the top portion works as a aerobic. So both aerobic and anaerobic treatment itself happen in this Phytoedit bed. So the treatment efficiency is going to be increased and improved. Next. Yeah, we applied this Phytoedit technology more than 250 places across India, and those are successful running. And we know the cause because the Phytoedit technology doesn't require any chemical, no electromechanical, very less power, and very low operation and maintenance. Next, please. So these are some salient features, and the technology has been approved by Government of India, Government of Maharashtra, Government of Madhya Pradesh, and all these features I already told. It's very low energy, low operation maintenance, no odor and mosquito, since sewage is going through subsurface, so there is no water logging. And I show some of the pics of sewage treatment plant, so you yourself can see the aesthetic and its adaptability. And finally, as I continuously telling, any technology should be cost effective as per the life cycle cost analysis. Next, please. These are some treatment efficiency and which are meeting the required standard, and which can be used whether it's urban context, whether it's a decentralized manner, or whether it's in rural areas. Next. Yeah, so the sewage treatment plants look like that. So I think it's so landscaping and aesthetic also, and at the same time it's treating the sewage. So next, please. Yeah, can we go to next? Yeah, so these are some other plants that we are using this Phytore technology, whether it's industrial water, whether it's organic wastewater, whether it's products, or whether it's on resorts. Next. Yeah, we are just removing the pollution from the river and whatever the drain which are meeting into the river. So this is one of the practical case of Harmu River in Ranchi, where we are rejuvenating and try to remove the pollution from Harmu River with the help of sewage treatment technology that's based on Phytoedit on the bank of Harmu River. Next. Yeah, I think this is one of the critical and very important issue which I would like to share. That's in Godavari Kumbh, the Nala which is flowing with the sewage and the system itself installed in the drain itself, and the Godavari River where the Shahi bath was supposed to be there. And before the Kumbh started, the pollution level has been reduced drastically, and there's no foaming and kind of soaping in the river. Next. The second important issue in the urban context is lake. We all know how the conditions of lake is going to deteriorate because all lakes are used by the participants and the citizen and netizens of the city as a solid waste dump site, and whatever sewage and industrial wastewater is just going into the lake. Next, please. So I think that's the ex situ lake treatment concept and in situ lake treatment concept. So if some sewage is going into the lake, so we can treat and then allow the treated and good quality water into the river. The second one, if you provide some treatment in the lake itself, so how best we can improve the water quality. And recently, Niri has successfully done the lake rejuvenation of Telibanda Lake, Raipur, Sambhaji Lake, Solapur is going on. And we are working with more than 100 water bodies in Delhi, with Delhi government, whether it's Delhi Jal Board and whether it's irrigation and flood control by these sustainable treatment technology. So we are not taking any chemicals, electromechanical and other issue to rejuvenate our water bodies. Next, please. Yeah, this is one of the good example of Shadra, and Shadra Lake is in Delhi, which is only rain fed, and rest of the 8 months it's just like dry. So we are treating the sewage, and that to be quantity of 30 lakhs liter per day, and rejuvenating and reviving this lake. So we can see some of the coming slide. We can go to the next slide. Yeah, so this is the perspective view, how, because we all know all human civilization started near the water. So if we can create the good water body, so we can create so many good aesthetics and happening and movements of the tourists. So that was the concept. Next, please. Yeah, so this is the perspective view. Next. And right now all things are going. So this is the way we are treating 30 lakhs liter of sewage per day with the Phytoedit technology. Next. Yeah, so this is the 30 lakhs liter daily water comes. Next. Yeah, so we can go to next. Yeah, so from these treatment plants and units, and very unfortunate, I should say, the sewage water is also mixed with the industrial wastewater. So it's very difficult to treat, but fortunately, these concentrated wetlands are taking care of the sewage. And if you see, this is full of plantation and garden, which is treating 30 lakhs liter of water per day. Next, please. Yeah, if you see, this is the quality of water, and this water is directly going into the Shadra Lake for its rejuvenation and its beautification. Next. So this is the overview view. Yeah, we can go next, no issue. And this is the in situ lake treatment where we can make this floating phytoraft. So we take care of both organic and nutrient pollution, and the lake can be treated over the time and can be make the river system rejuvenated. Next. Yeah, so these are the floating phytograph. Next, please. We applied in various lakes, whether it's Makmali Lake, Thane, whether it's a Siddheshwar Lake, and all these water bodies is getting some wastewater and industrial wastewater by the nearby surroundings and creating the pollution in the lake. Next. Yeah, so this is another pretty good example of Telibanda, where we use the sustainable and eco-sensitive technology, and we are reviving this Telibanda lake. Next. So like our partner is BHEL, and the concept was nationally awarded the utilization of eco-sensitive and sustainable treatment technology for revival of any water body in India. So these are the work we are doing for lake. Next, please. Yeah, so another big challenge is coming in the urban context. So whether it's the whole India or whether we talk about Mumbai Metropolitan Region, like if you talk about like still 60% collection efficiency, if you talk in terms of Mumbai, so still 40% sewage is going into the drains and nalas and big nalas, and finally meet into the creeks and khadi and the beaches. So whether we can think of restoration of all these drains and nala, again with the help of ecological units. So that was the big challenge, but CSIR came with the sustainable treatment technology. So we can treat the drain water or nala water itself in the drain, and we can think of its reuse and recycle of treated water, even for the sake of dilution of the downstream, whether we are talking about the creek. And if you talk about the creeks, I think 3 creeks generally comes in my mind about Mumbai. That's a Thane Creek, Malat Creek, Manori Creek, and Meethi River are creek. And we know that's it's a quality and its encroachment and its sludge issues are well known to all Mumbaikars. So whether we can go for some type of treatment technology. Next, please. Yeah, so CSIR-NEERI has designed and developed this restoration of Nala with ecological units. Again, the phenomena is very simple and nature-based, and we are treating this rainwater and Nala water with the help of physical and biological treatment. Next. Yeah, so these are any Nala if you see. Again, we are taking opportunity to use these open drains and Nala as a solid waste dump site. So one can see all these things are happening in all our open drains and Nala. Next. Yeah, so this is the drone view where we can make the treatment in the drain itself by providing different pool and channels, and the water can be treated itself in the drain. Next. Yeah, even that flood water can also help. So whatever treatment technology we are using, so that remain in the treatment and there is no hazard and no harmful with the technology. Next, please. So we can see the before and after scenario of any drain and that NEERI has successfully designed, developed and implemented many places in India. Next, please. Yeah, so if you run that video, you can see the drain water can be this much crystal clear. So, and it's designed and implemented in Niri, Nagpur, and it's successfully implemented in Prayagraj before Kumbh Mela. And we are fortunate, like 1 or 2 places are coming in Mumbai. So very soon we can see this in situ Nala treatment technology in Mumbai itself. So the technology has been implemented in Prayagraj, UP, and NIT Garden in Nagpur. Because they are reuse and recycle of this treated wastewater for the maintaining of gardening. And Nagpur it's hot during summer, and they don't have facility to get water for daily gardening purpose also. So these are the drains, and some more drains are coming across India. That's in Pune, Daman, Diu, and recently it will be coming in Mumbai also. Next, please. Yeah, so these are some of the concept and its patent and its commercialization about this particular in situ Nala drain treatment technology. So not only we can reduce the pollution in river, but at the same time we can think of rejuvenating of our creeks and ocean water bodies, which directly discharging and taking the sewage and wastewater. Next. Yeah, Next, so this is another kind of concept and design. So whether these gates can be opened during the flood time, so how the flood water can go from the drain, and after the rain overs, so again we can treat and reuse and recycle of this water. Yeah, so in the last, I just would like to share some of the major issues we need to talk, and I think it's a good opportunity. In association with Mumbai First, I'm taking this issue, the impact of urbanization on mangrove growth around Mumbai. Although the mangrove is very sensitive issue, but at the same time, its growth should not be haphazard, so we can create the ecology. So we know the mangrove system is very fragile, because it's create the colony for flora and fauna, it control floods, and it's capture nutrient, and it's recharge groundwater also. But what happening, all these creeks which is surrounded by mangrove, so all these creeks are getting deteriorated in terms of its water quality by discharge of solid waste and liquid waste, and the sedimentation is happening because of all these demolition waste, as well as the liquid discharge and industrial wastewater, and all sewage finally going into the creeks and ocean, so which are disrupting the ecology of the mangrove. And at the important, the blocking of navigational channel. So what happening, the truly fact, mangrove is increasing in MMR, but it's not increasing towards landward side, but it's increasing towards the waterward side. So that's a big concern and challenge we need to look into. Since the same thing is happening, still the water channel is keep on reducing. So there will be no proper monitoring and no movement of the water and tidal water which flush these creeks. The second important issue, these creeks and these mangroves are help the flood water from the tidal side. But just imagine when the overgrowth of mangrove in the creek itself, so there is a chances of more time which reside the flood water which are coming from the city. And that's happened in Mumbai, not only in Mumbai, in Vasai Virar. What are the natural drainage has been destructed and reduced its width, and whatever width are there, and naturally and with the facilities of anthropogenic activities, we are providing these small creeks and nalas to favorable conditions for more growth of mangrove. So I request Ms. Tan, Madam, who is coordinating this particular session, can you allow me to, so I can share one video where I can discuss that R&D and implementation part of this mangrove growth in and around Mumbai. So can I?
So if it is a short video, I think we can.
Yeah, of course, it's a hardly 3 minutes video.
I hope that is okay with the organizers.
Yeah, Dr. Mehta, yeah, please.
Yes, it is okay. Please go ahead.
Thank you.
Creeks are the fragile ecosystem which plays a crucial role in groundwater recharge, nutrient capture, controlling flood and filtration of sediments. This natural cleansing phenomenon of creeks makes them a suitable place for sewage and effluent discharge along with the solid waste of nearby areas and industrial establishments. CSIR-NEERI has carried out a research study on the impact of urbanization on creeks of Mumbai, that is Thane, Malad and Manori Creek. The methodology adopted consists of collection of satellite data, deals with the object-based image analysis and change detection and life expectancy analysis of creeks. False color composite images are very useful to see the finer variations in near-infrared reflectance, which is related to photosynthesizing vegetation. Land use, land cover, LULC, analysis was performed to quantify the changes in the growth of mangrove and creek widths. LULC classes were categorized into 9 classes. Results showed that there is an overall increase in the spatial extent of mangroves and reduction in width of the creeks. From 1972 to 2016, mangroves around Thane Creek have increased from 50.7 kilometers square to 57.6 kilometers square. An average width of around 500 meters has been reduced in the middle stretch of the creek. The minimum and maximum width observed in Thane Creek in 2016 are 93 meter and 8,871 meter respectively, with a standard deviation of 2,633 meters. Various profiles, that is A to K, where widths have been measured are shown. It is estimated that width of the creek would be decreased considerably in upcoming years. It is estimated that the average width of the creek in lower portion will be reduced by 2% in 2025 and by around 10% in 2050 as compared to width in 2016. Life expectancy analysis has been carried out for Thane Creek, and a further reduction in the width of the creek is projected for the years 2025 and 2050. In Mallard Creek, mangroves were constantly decreased from 1972 to 1994, maybe due to development, as highlighted by yellow circle, and slightly increased during 1994 to 2016 because of the growth of mangroves along the mudflats of the creek. The creek width was decreased from 1972 to 2016. Similarly, the life expectancy analysis has been carried out for Mallard Creek, and it is projected that a higher percentage of reduction in width is estimated in the lower portion of the creek, which is the reverse of Thane Creek. The coverage of mangrove in all the portions of the Manuri Creek has increased significantly from 1972 to 2016 as contradictory to Thane and Mallard Creeks. The mudflats and salt pans are reduced considerably during 1972 to 2016. The average width of the creek in all portions has also decreased constantly from 1972 to 2016. Similarly, the life expectancy analysis has been carried out for Manuri Creek, and it is projected that a maximum reduction in width is estimated in the upper portion of the creek. Niri has proposed recommendations such as restriction on haphazard development activities besides creek. Solid and liquid waste should not be discharged into the creeks without treatments. Attention towards formation of mudflat and unchecked growth of mangroves. Ban on dumping of solid waste near the banks of creek, and timely cleaning and dredging of the creek. Proper legal methodologies should be implemented to monitor the development activities near creeks, as they play a crucial role in ecosystem services. The research paper for the studies published in Journal of Coastal Conservation, and the said research has also grabbed the media attention, and an article was published by Hindustan Times. We acknowledge Director, CSIR.
Hearing and yeah, thank you, Dr. Mehta and Ms. Tandon for this opportunity, and looking forward to more solution and water usage and wastewater management in Mumbai Metropolitan Region. Thank you.
Thank you so much, Dr. Vijay. I can say that your presentation is a very good example of what we are talking these days about the green pathway to recovery from the current situation. I mean, all of us know that there's such a huge gap between the wastewater infrastructure that we have and what we need. And this huge gap cannot be simply met with centralized gray infrastructure. We need a green infrastructure to keep on growing and bridging this gap very fast. And the constructed wetlands and the mangroves especially play a very, very important role in this. And I also want to thank you, because this sets a very good backdrop to my presentation later on. So thank you so much. And now we invite our next presenter, Ms. Lubaina Rangwala. She's Senior Manager at Water Resources Institute. And the topic of her presentation is Issues of Access to Water and Essential Services, its implications on public health, especially in vulnerable communities in Mumbai. Now, Ms. Lubaina is an urban planner and architect. She has work experience in India as well as in the US. She has led the Urban Development and Resilience, she leads the Urban Development and Resilience Initiative at WRI Ross Center. She has earlier also led the development of urban community resilience assessment tool, which is a very important tool. Now she is involved in, developing urban climate resilience strategies for most cities based on this. And her focus is on vulnerable communities and local institutions. So welcome, Ms. Lubaina, and over to you.
Thank you. Yeah. Hello, everyone. Good evening. Thank you for inviting me, Dr. Neville, and thank you for the gracious introduction, Ms. Tandon. I'm just going to take a minute to share my screen. So, as Ms. Tandon introduced me, so today I'm going to speak about water access and the importance of water access as an indicator to ensure collective health and well-being in vulnerable communities. Basically what I'm going to cover is more sort of the context of the socio-economic context of water access in the city of Mumbai, and not really get into any of the solutions, just maybe speak about certain kinds of policy barriers, some events that have happened to overcome that, and to talk about the kinds of implications that we are sort of headed to if we don't really take this quite seriously. So it's going to be quite different from some of the presentations that I've seen this far. What I'm going to first lay out is the city context and what water access in Mumbai really looks like taking a closer look at it. Then talking about some global contextual numbers on water inequity, and then finally the kinds of associated risks and vulnerabilities we see in cities. So this is a map of the Mumbai Metropolitan Region. We are spread over an area of 4,000 plus square kilometers, and an estimated population of 26 million people. And Greater Mumbai is what is commonly known as the Mumbai city area, is only 10% of the region, but a population of almost half of what the regional population is. So we're looking at extremely dense housing and living conditions, and quite a lot of pressure on our resources, whether it's water, whether it's sanitation, natural systems, etc. So just wanted to lay this out as we get into some of the numbers. This is a map that shows some of the slum settlements in the recorded slum settlements in the city of Mumbai, and you can see that they are basically dispersed. Settlements are dispersed across the city, from the south to the northern suburbs. And fairly large agglomerations in certain areas of the city. 41.8% of Mumbai's population lives in informal settlements. This is based on the census 2011. I'm sure the numbers are quite high now in the last 10 years, in the 10 years, past 10 years. This map shows the drinking water access, drinking water within people's premises. So based on this map, one can say that 60 to 80% of most households in Mumbai city, so within Greater Mumbai city, have access to piped water in their homes. And as per the service level benchmarks, which are essentially for city benchmarks, not for the region. In fact, 100% of coverage is what is stated for municipal water supply connections, and a supply of 135 liters per capita per day. However, a closer look at water access in the city reveals that 20% of the city of the households in Greater Mumbai do not have a water source within their premises, and an average continuity across the city, the average continuity of water supply is only 2 hours. So while we theoretically get 135 liters per capita per day, people are having access only for 2 hours in a day. Additionally, in most settlements, people have access to piped water, often as community taps. So it's shared, within 5 or more households. This leads to extreme sort of exposure to contamination and all kinds of, disease spreads. These are some numbers, disaggregated numbers based on for Greater Mumbai. So Greater Mumbai comprises of 2 districts. There's the Mumbai city district, the island city, and then there is Mumbai suburbs. In Mumbai district, from 10 census wards, that is about 47% of the district population, 30% households do not have access to piped water within their homes. And in the Mumbai suburban district, that is approximately 30 census wards, 73% of the district's population does not have access to, that is 73% of the district's population. From that, 28% households do not have access to piped water within their homes. Housing conditions across the city, there are less than 35% of the houses in Greater Mumbai are in good condition. When you look at sanitation numbers, 47% households do not have a latrine facility within their premises, and 45% depend on public latrines as their source of sanitation. So when you actually disaggregate that, whether it is 60 to 80% based on the census numbers or the 100% coverage that the SLB is talking about, when you disaggregate it by the kinds of living conditions in which people are going through their everyday life, the picture is very different, right? These 2 maps are talking about, on the left, we're looking at water access, and on the right, we're looking at sanitation, latrines within their premises. And clearly what you can see is that while the drinking water is at 60 to 80% coverage, most of the wards within Greater Mumbai fall in the low to poor access to sanitation category for latrines in the premises. So either people have absolutely no access, so they have to use pull-ups, etc., or they have common toilets within their settlements. So here, I'm going to get into some of the findings from a report that the World Resources Institute produced. It's called the World Resources Report, focused on, and the main thesis was towards a more equal city, essentially saying that if you don't have equal access to good, reliable urban services, then your then your kind of growth and ability to thrive in a city is going to be largely hindered. So this paper, Unaffordable and Undrinkable, focuses on water access in the Global South. And the main sort of framing paradigms for looking for assessing water access are 3, right? Safe, reliable, and affordable. So these are very important 3 indicators, not only just looking at coverage as a benchmark, but understanding that reliability and affordability are also additional factors to consider in terms of equitable access. So there are some diagrams I would like to share from this paper, which look at city level numbers. So in Mumbai city, you can see that people have access, largely average access, for 7 hours a day for 7 days a week, which is fairly okay. Like it's moderately good. But when you look at the slum that they have studied, which is Siddharth Nagar, people have no access to piped water in that particular slum. So and what is also to be understood is that intermittent service is common in most, even in buildings and old buildings, you have intermittent water supply, which lowers the water quality because it has, it's open to then leakages and contamination, and, people sort of like smuggling, having to resort to all kinds of measures to access water, and that results in, all kinds of contaminations. So also, when you look at the treatment figure on the right, 75% of Mumbai city residents do not treat their water. Also, because we have good access to very good safe drinking water, but the way that it comes to our house, with so many sort of infrastructural issues, it is quite surprising to see that 75% do not treat their waters. But surprisingly, that's the same case in the slum, where they don't have access to piped water. So these are some things to kind of note, right? Then looking at the source. So if we are not getting access through piped water, then what are the sources, right? So in Siddharth Nagar, you have most people depend on tanker trucks for their water supply. So and despite this, and this is despite the city having high coverage, the burden of unsafe and unaffordable drinking water largely falls on the poor and most vulnerable in cities, which is really to be considered. This is a really interesting diagram that now talks about the price comparison. So for one tanker of water, it is 52 times the same amount of water that one would have access to, 52 times more expensive than piped water for the same amount. So so this is basically the kind of the kind of prices that the poor are paying for access. But when you actually look at the global context, right, globally across the global south, urbanization is the urban population is on the rise. And increasingly you are seeing a service gap that is also sort of increasing. So there is there is clear evidence that is showing that inequity is also on a rise, right? Because we are not being able to think about how to meet this demand that is growing in our cities. So why is this the case in Mumbai? So the barriers are not only technical or monetary barriers, but largely these are legal, institutional, and political barriers, because in Mumbai you have, and across India, you have notified and non-notified slums. So slums that are notified by the census then have access to some forms of government services, urban services provision. But in non-notified slums across Indian cities, this is not the case. So 59% of slum settlements in India are non-notified, and Mumbai has apparently the largest slum population of any city in the world. I'll have to check the numbers on that statistic, but with more than half of its population living in informal settlements. So that is really key. Nearly half of Mumbai slums are non-notified. The divide between the notified and non-notified slums is then tied up to cutoff dates. So cutoff dates, now in 2000, there was a cutoff, like they set up a cutoff date that everyone who has moved into this house before the year 2000 can apply for a notification, and everyone who cannot produce that proof then is non-notified. And so that has really actually led to quite a significant crisis in Mumbai slum communities with respect to water access. But there have been some small victories. In 2014, the Bombay High Court ordered the city government to extend its access to Mumbai's water supply to residents living in non-notified slum, and this was a sort of vital victory that was won. And Pani Haq Samiti was actually one of the most important groups that has repeatedly over years, fought for this litigation. Yeah, the public health, the public interest litigation that they filed. And it was, and the judgment was came on the basis of two important aspects that that need to be highlighted. One is that that it was basically on a human rights framework that they managed to override the city legalities, holding that right to water is central to the right to life guaranteed by the Constitution of India. And second is the court emphasizes that water access should not be tied to property rights. So even if you don't have security of tenure, you should still have right to water. And these two sort of arguments allowed the court to overthrow or cut through the legal barriers and allow for access. But of course, this has just been sort of, I mean, very recently also there were like this kind of back and forth with the court is continuous. And while, you know, people have real kind of issues, these are some sort of newspaper news articles of other cities across the world. So you can see from Cape Town to Bangalore, you know, cities are across the world are at a tipping point in terms of water access. And this is something that also needs to be be kind of, you know, as part understood as part of the sort of larger problem of water access and water as a resource. 5.7 billion people are likely to face water scarcity at least 1 month every year by 2050. And 350 million more people are going to be exposed to deadly heat in cities by 2050. So, I mean, these are really some startling kind of figures. This is an interesting map of the land surface temperature of Mumbai city, with the slum pockets now overlaid on it. And you can see that most slum areas are actually in high heat areas of the city, high heat stress areas of the city. And this again, you know, poses extreme public health concerns in slum communities where they do not have access to water to alleviate, you know, dehydration, and it results in a myriad of kind of health issues and productivity loss, livelihood loss, etc. So, you know, thinking about some of these implications. So the lack of safe, reliable and affordable water has resulted in a public health crisis in Indian cities, and really our children in slum communities are at the forefront of this crisis. You know, there are recorded you know, evidence of increased exposure to diarrheal illnesses, increased incidence of malnutrition, increased child mortality in slum communities. And from the paper that I was referring to from Ramnath and Murthy 2015, their study compares, you know, one slum community in Kurla, which is a non-notified slum, and compares it with numbers from notified slums and with the city level. And they've actually concluded that children in non-notified slums are actually more exposed to these health issues of diarrhea, malnutrition, mortality, than even the notified slums, and definitely much more than the city level averages. So these are some things to actually think about, that you know, it's been quite a few years that these legal barriers have been in our ecosystem, and it's time we sort of start thinking about the human rights cost of some of this. Then looking also at the idea that lack of access also comes with various other, you know, you have, if your sources are contaminated, you're exposed to waterborne diseases like cholera, unsanitary conditions of filling water, and, you know, spillages, leakages, etc. are also becoming breeding grounds for mosquitoes, and therefore more vector-borne diseases in slum communities. So there is clearly a very high public health cost that we are incurring because of the kind of situation that people are living in this city. And really, if not before, the past few months of us living through this pandemic has really shown that when we think about hygiene and sanitation as our only kind of personal care health mitigation strategy, what we can do to save, to keep ourselves safe, is really keep things sanitized. And we're saying that most residents who live in these communities have limited or no access to safe, clean and affordable drinking water, and therefore are most exposed and vulnerable during the COVID-19 pandemic. So really, I just want to kind of end on this note to pose some questions, I guess, to policymakers and practitioners in the audience as well, to think about what could be some possible solutions that one can think about, and how do we then think about the socioeconomic cost of water as a resource, while we are thinking about technologies and planning mechanisms to improve access, to reduce contamination, to improve efficiency, etc. How do we also ensure that the socioeconomic costs are being addressed in our solutions? So yeah, I'm going to end with this. Thank you very much. It was a pleasure speaking about this issue for you all. You can reach me at this address.
Thank you, Lubaina. Thank you for a lovely address. It was an eye-opener for all of us to see the conditions prevailing in Mumbai and the predictions of the 2030 and 2050, what we should expect. And this reminds me of the World Bank report about around 60 crore people in India are going to face a great risk from extreme climate. And large states like Maharashtra, Tamil Nadu, and Karnataka are under the grip of acute drought conditions, while in the same states, we have few places which are susceptible to excessive flooding. So it's water, water everywhere, not a drop to drink. And that's the story, but it's sad, and we have to do something about it. And that's exactly why we've organized this webinar. Ladies and gentlemen, now it's time to get the last speaker on board, and that is none other than Ms. Tandon. She already has been introduced by Dr. Nandan Maluste, but for those people who've just joined us, she is an architect planner who specializes in water resource management. She has over 15 years of work experience in the urban development and climate change and sanitation fields. She's also supported international funding agencies, state and local governments. Her forte lies in intersectoral integration, and her extensive experience with BOP communities, urban local bodies, and international organizations provides her an understanding of local as well as global perspectives. Ladies and gentlemen, may I now present to you Ms. Tandon, Meesha Tandon. She's a subject specialist on urban water climate change. Meesha, the floor is yours.
Dr. Mehta, thank you for the very generous introduction. So before I start my presentation, just a small request to all the attendees. If you have any questions for the previous presenters or for my presentation, please type them in the chat box, because after this presentation, we'll be taking up the question and answer session. So my presentation today is on integrated water resource management. I will try and look at it from the climate perspective, from the long-term perspective. How can we plan our water resources to meet the requirements for, say, a 2050 or a 2060 Mumbai, whilst considering the climate aspects? So just to set the context, Mumbai will need around 6,500 MLD of water requirement by 2041. And it plans to meet this requirement through new dams, rainwater harvesting, reuse and recycling, along with other approaches. There's also likely to be a 40% increase in the water requirement for industrial and commercial users. Now, Mumbai is targeting to reuse its treated wastewater, approximately 20% of that, which will be around 500 MLD, and the remaining 80% will be discharged into the sea. Now, we are aware that the revised norms for wastewater treatment require tertiary standard treatment. So let's hope that with this we can reduce the extent of marine pollution and contamination. And another important point that was mentioned was that they intend to look at urban forestry, how they can include it. So that's where the green infrastructure sets in. So I will talk about the alternative approaches. You always have your gray infrastructure, but there are alternative approaches that you need to inculcate. For example, like if we are dealing with a pandemic, we are not only depending on a vaccine. We're looking at personal hygiene, we're looking at physical distancing, we're looking at many other measures. So similarly, while we're looking at the water context for Mumbai in the future, along with our water supply, the demand supply shortages, and the wastewater treatment facilities, there are alternative pathways that we should consider for a sustainable and green future. And that is what the presentation focuses on. So I'll request the presentation to be played, please.
So hello everyone, and as you've been told, I'm Meesha Tandon. I am a subject expert in urban development, governance, water resource management, and I'm also a social entrepreneur. So today I'm going to talk about integrated water resource management, or IWRM. But I'll look at it from the climate perspective. How can IWRM be a solution to some of the climate woes that we are facing? So I'll introduce you to the concept of IWRM, even in the urban context. We'll look at the climate change perspective. We'll try and look at Mumbai. How are the water resources likely to get impacted by climate change? And then what are the alternate solution pathways? Now, why I say alternate solution pathways is because I'm not going to talk about the hardcore engineering options, because I'm sure a lot of you have a lot of expertise in this sector. But what I'm going to talk about is the alternative solution pathways that we can take up, which might be at a local level, which might be at a city or even a global level. But then I think this beginning needs to be made. It might not start as a complete answer to our solutions, but it can definitely get us there faster. Now, IWRM, or Integrated Water Resource Management, I'll not get into defining it, but I'll focus on the 4 key elements that it promotes. The first is that your catchment should be your unit for planning. The second is that all aspects of water, be it drinking water, wastewater, recycled water, storm water, groundwater, surface water, they're all part of one single loop. There would be inflows into the system, there would be outflows from the system, but you have to try and close this loop to the extent possible. The other thing is that it does not only limit itself to the water sector. It also looks at the interaction of water sector with other sectors like land use, transport, waste management, biodiversity. And at the core of it all is the community. So that is the major component that you need to focus on while you look at an IWRM based approach. So now the concept of IWRM is based on Dublin principles. I'll quickly go through some of them. The main and the most important one is that fresh water is finite and vulnerable. The next one is that you need to look at water management through a participatory approach, which involves the community. The third one is that women play a central role, because in a way they're the ones who are most impacted by water crisis. And the last one is that water has an economic value. So now IWRM based approach looks at the catchment in a holistic manner. You have to look at the geology, hydrology, topography, land use, where are the settlements, and many more. And a complete analysis of these gives you the way forward. Another aspect that you need to consider is who are your various stakeholders: residential, commercial, religious, even the ecological users. And most importantly, it does not have to limit itself to human users or users. You also have to look at ecological users and users, including these. Now, European Water Framework Directive is a landmark directive which has been implemented since 2000s, and it is really getting into promoting and institutionalizing this basin level approach for planning. It aims at pristine river quality, and it promotes the systems based approach, which looks at the interlinkages and the interdependencies of ecosystems, not just looking at them in isolation, but the interlinkages between ecosystems and settlements and various other users and users. Now, when we look at IWRM from an urban perspective, the term we use is called IUWM, or Integrated Urban Water Management. But I think maybe it should be called Integrated Urban Water Resource Management, because that is what the main aim of this approach is, that you should look at water in all its forms as a resource, be it wastewater or be it normal surface water. Now, IWRM is the larger picture. IUWM is a subset of IWRM, wherein we focus on the urban aspects. But as we all know, water is not limited by boundaries. Now, looking at the climate change perspectives, if you look at this band that is there, this is indicative of the areas which are likely to be most impacted by climate change. And this includes a large part of India. And what is also important to note here is that climate change is likely to increase the amount of disasters and extreme weather situations that we face. And most of these are related to water directly or indirectly. So to tackle climate change, Paris Agreement was signed in 2015 as a global agreement to combat climate change. Now, what this aims at is to limit global warming to 1.5 degrees Celsius, maximum 2 degrees Celsius. But the way we are headed right now, we're probably headed towards 3 to 4 degrees Celsius of warming. CO2 reduction by 45% of 2010 levels, and the main thing that another main factor that Paris Agreement emphasizes is that we should try and go carbon neutral by 2050. And to work towards climate change, sustainable development goals, which are a set of 17 goals with separate indicators, have been formulated. And goal number 13 aims specifically at climate action. Now, if we look at the water supply scenario in case of Mumbai is basically dependent on these 7 lakes in the catchment area for its water supply. In terms of wastewater, it has a significant capacity to treat wastewater, but there is also some portion, especially from the slums, which is going untreated and is being discharged into the sea directly or indirectly. There is also an issue related to contamination of the marine ecosystems because of this. Also, the treated wastewater from some of the STPs is not yet meeting the standards. So another important aspect that we need to look at is nearly 3,000 MLD of treated wastewater is being discharged into the sea. That is a lot of water that can be reused. What this also shows is that there is a sort of a linear flow of water. The loop of water in and around Mumbai is not really closing here. So now all of you must be aware of the Mumbai floods in 2005, where around 1 meter deep rainfall had fallen on that day in a 24-hour period. And obviously the intensity of the rainfall was much more than what the drainage systems could handle. Now, even in 2020, there were meteorological department predictions that the rainfall intensity for Mumbai might be around 30 to 50 mm per hour. And this is much above the standards for which our drainage systems are designed. So we need to be prepared for more and more rainfall intensities over shorter periods of time. And that can lead to more flooding in the future. Cyclones like Nisarga are also increasing in intensity, and more cyclonic storms have been seen in the Arabian Sea. And this is a study which was done by a group in America, and this shows how the Mumbai sea level rise is likely to inundate a lot of land by 2050. Now, so looking at some of the climate change impacts that are likely to impact this region, the first one, as I said, is likely to be sea level rise. The second one is likely to be cyclonic storms, which might be aggravated because of urban heat island effect. The next one is the floods that are likely to also go up because the rainfall intensity, which is the amount of rainfall that is going to fall within a given period of time. So that amount of rainfall will be more. You're likely to get more rainfall over a lesser period of time. And that again is going to exceed the capacity of the existing drainage network. Another impact that is likely is going to be temperature increase. We are already witnessing hotter summers and shorter winters. The increase in temperature is likely to cause more evaporation and is also going to lead to increased water consumption for cooling. And the other impact could be on water cuts, although this is not a very prominent factor right now, and Mumbai faces around 10 to 15% water cuts. But if we do not pay attention, then maybe by 2050, this also could be an important factor. And some of the reasons for this could be the lack of forest cover maintenance in the catchment of water bodies, and the erratic rainfall patterns that we're getting. So let's look at the alternate solution pathways. For sea level rise and storms, I'll not go into the details because these are part of a global cycle. But some of the actions that we can take at our level to reduce the impact can be mitigation, which is we try and reduce our carbon emissions to the extent possible. Adaptation, which means we prepare ourselves for these impacts. The third is climate insurance, which I think needs to be promoted in India in a big way because of the kind of climate impacts that we are seeing. The other is building bylaws. You can change your bylaws to adjust to the likely impacts that you might face in the future. From the perspective of storms, Mumbai has had mangroves which have acted as a shield from the storms, but these mangroves are getting depleted at a very, very fast rate. So probably we need to put in more efforts at reviving these mangroves because they are your natural layer of defense. The other could be that you need to start building your disaster management and preparedness capacities. And thirdly is that you constantly work with the communities to prepare themselves and to build in such a way that the impacts of the storms do not really have a significant impact. Now, from the perspective of floods and water cuts that might be faced in the future, what are the alternative solution pathways that we can take? The first one can be, we can be prepared to know when these floods are likely to happen. This can be done through improved early warning systems in the entire catchment area. The other measure could be catchment afforestation. Studies globally have shown that a forested catchment is going to lead to lesser runoff or lesser discharge than a catchment which has a lot of urban areas and hard surfaces. So wherever possible, we should try and increase the forest cover, even if not in large patches. This can be done in smaller patches. The third one, which the pandemic has also shown us, could be urban agriculture. This can really come up in a big way in Mumbai because, there is a lot of commercial benefits from this as well as environmental benefits also. The next measure could be redesigning your drainage for increased intensities of rainfall. Another option could be building your blue and green sponges within the city. I mean, if we look at this image of Mumbai, we see so many hard surfaces. Obviously, with the kind of character that Mumbai has, you will probably not be able to find large patches where you can do plantations, but then you can find spaces to plant 1 or 2 trees at a lot of places. So these together can act as a green sponge, and you can build blue sponges by conserving and reviving your local water bodies, which can retain the water during rainfall. Urban forests, as I said, can play an important role. And you need to look at options for diversifying your water portfolio. You need not to focus on only surface water or only groundwater. It can be a mix of a lot of options to make you resilient. And don't just look at now, but look at 20, 30, 40 years down the line. How can you still be resilient by, say, 2050, 2060? So now I talked about early warning solutions. I'm sure to some extent this is already being initiated in the catchment area of Mumbai as well. But this is an example from Ebro River Basin in Europe, where instrumentation of the entire catchment has been done, and real-time data is available and linked to a software which can give you a warning whenever there is heavy rain in the catchment and there is a possibility of flooding anywhere. So that gives you that time gap for any action that you might want to take. Now I talked about diversification of water portfolio. The graphic you see to the left is diverse. It is a diverse water portfolio. It's not putting stress on any particular ecological resource. The load is evenly distributed, and what is important is that a significant percentage is coming from reuse. Now, as we all know, Singapore is a leader in this. They have this new water, which is treated wastewater, which is used for potable as well as non-potable purposes. Presently, around 40% of their supply comes from this new water. And by 2060, their target is that desalination and new water should account for 85% of the supply. Nagpur has a very good case example for wastewater reuse. So how are we thinking of diversifying the water portfolio for Mumbai in the future, say by 2050 or 2060? Now, alternative solution pathways in terms of blue and green sponges that I talked about could be in the form of these sponge cities that we can learn from, where green areas and ponds and bowdies and other water bodies are being revived so that they can retain this rainfall. Sustainable urban drainage systems which puncture the hard surfaces that have been created. Our traditional rainwater harvesting structures which help in retaining a lot of water and making it available during lean periods. Now, all these efforts, along with the urban forestry concept that we talked about, can lead to reducing that flood peak that I have highlighted there. And that is the most important component that we need to focus on. Time lag so that this flood peak can be flattened. Now, Merkel talked about the green recovery from this pandemic. Now, this is not just a safe statement, but it also makes a lot of business sense because SDGs alone are a 12 trillion USD market. And India alone needs around 2.6 trillion USD investment to meet the sustainable development goals. And over 1 million green jobs are likely to be generated by 2050 in UK alone. So you can imagine the extent of this green market that we'll have in the future. And 42 million green jobs globally are likely to be in the renewable energy sector alone, and water is a part of it. So from the perspective of my organization, we have these platforms where we are conducting webinars to spread awareness on climate change and water resources. We've also done training programs with students in schools and colleges in tier 2, tier 3 cities to sensitize them on these aspects. We also have a climate leaders platform where we are developing partnerships with the national and international organizations to take initiatives towards climate adaptation and mitigation related measures. And we also have capacity building expertise, as well as we can start development of consultative platforms on alternate solution pathways. So these will mainly focus on involving the community and the grassroots level organizations, as well as local and state level authorities to start this dialogue on alternative pathways. So thank you very much, and I hope this presentation will promote this dialogue on alternative pathways. And that's my email ID. You can contact me on this. Thank you very much and have a great session. So, right, I hope you liked that presentation, and that was the last presentation for the session. Now, because we have limited time, we'll take up some questions. And for the question and answer session, I would like to invite Dr. Mehta, Mr. John, and Ms. Lubaina. So welcome all of you. And I'll start with the questions. So the first question is to Mr. John. Please elaborate on performance of CETP in terms of water parameters. Which ones are harder to meet standards? So Mr. John, could you answer that? Mr. John, you are on mute. Please unmute yourself. Yeah.
I'm sorry. See, the parameters is difficult to meet or difficult to attain.
The volume is really low. Is that at my end only? Could you place
now,
it? Yeah.
Now,
Yeah, it's better. Yeah, better.
Thank you. Thanks for that. See, the parameters we are finding it difficult to maintain are the COD and BOD. The reason being, I was mentioning in my presentation that the effluent that we receive is promiscuous in nature. And because of that, the ratio between BOD and COD is not always in the right ratio that is required for biodegradation. So we need to keep effluent in store and then mix it up and see that you get the right proportion of COD, BOD. And another parameter that we find it difficult is the toxicity factor. You know about that. So another is the color. Color is, of course, there is not much standard as far as color is concerned. But then color is again, it's a social stigma parameter. So many times we have this dye industries in our area. So the dilution is the only way by which we can now reduce the color. And we are working on other technologies, so but the volume is high. That's why I was mentioning in my presentation, we are planning to go, we are now working on hand-holding our members so that we give them the technology, we help them out so that they handle the low volume at their end, decolorize it, and then they drain into the mainstream. So that otherwise what is happening is the entire effluent of the volume gets colored. Although it may be light colored, but there is a color.
Right. Thank you, Mr. John. The next question is not to any specific speaker, so I think anyone can opt to take this. Why do lakes froth? How can it be prevented? Who wants to take this? Well, I guess maybe I'll just try and answer it. So basically, the reason for frothing of lakes could be multiple. It could be from industrial effluent that is being discharged into the lake, or alternatively, it could also be because of untreated wastewater that is coming from slums or any untapped areas, which is directly reaching the lake or the river. So the problem with this frothing is that it is likely to be more from industrial waste, and in some cases it can even lead to inflammation. Like making the lake flammable to some extent. That has happened in some cases. And that's not really because of the frothing, but because of the industrial wastewater that is being discharged into the lake and the resultant BOD reduction and methane generation and sulfur dioxide and all that, all those gases that are being generated. So I hope that answers the question. The next question is by Mr. Madan Gopal. He is asking, how can I, as an individual staying in Mumbai, contribute to lessen the problems and increase the awareness about wastage of water, reduce, reuse, recycle formula, helping in raising those issues in the community? Anyone wants to take that? Dr. Mehta, do you want to take that?
I think first of all, it's I must compliment him for even thinking in that direction. The idea is this is, we have, I think, got used to the fact that we start pointing fingers to various government authorities to do what we say their job. But it's not that easy. I mean, we all have to play a role in it, and the citizenship has to also participate in this endeavor. So one of the things that he can do is to, look towards his community at this point of time, to start with his community where he stays around him, and create this consensus of saving water, reusing water, and also water conservation, like, create certain facilities jointly with people around him to create these water facilities around him, conservation facilities around him. And if he needs any help, we'll be too happy to help him. Mumbai First will be too happy to help him. And besides that, there are also ALMs around the areas where they can hear where they can meet and get information from them. And we will be too happy to connect them with them. And I must again compliment that question. It was very nice of him to have offered to help. And I wish more citizenship come out towards this type of a behavioral pattern change that is required to mitigate this issue.
Thank you, Dr. Mehta, for the very prominent reply. And I would also request you to join the Climate Leaders platform with my organization. We are trying to gather such like-minded people who want to spread awareness on these issues, and we are looking at nurturing them as leaders in the future. Another question by Mr. Madan Gopal is, why can't we fit individual water meter for all the households, as we have electric meter, and bill them individually instead to a society? so as to check individual water consumption. Anybody wants to take that? Mr. John? Mr. John, you're on mute.
See, the water consumption is already being metered, whether we be domestic or industrial. Because except in some clusters where for domestic use, they give it on a lump sum money. But otherwise, it is normally metered. Like in Mumbai and New Bombay, it is metered. It is the wastewater that is not metered. Whether it is in industry or whether it is in domestic, the wastewater is not metered.
But
So
the question here, John, is that why are there no individual meters like we have the electrical meters in our houses? Why don't we have similar water meters so that each household knows how much water is being used? And sometimes in the condominiums and other apartments structures, they have one single meter which goes to the building or the condominium, and then the water charges are accordingly divided as per the amount of people staying there or things like that. So I think this question is a good question. I think it's a question to be addressed for the future. At this point of time, we have many more priorities to take care of. First of all, there is no water for so many people, and they don't have access to water. We just saw the presentation. So that's going to be the first priority. Once they get water into their taps, that's the time we talk about having meters. But I must compliment you. It's a good question. You have a good vision for the future. And I think one day we may see this happen. Thank you.
Thank you, Mr. John and Dr. Mehta. And we are also getting more interested individuals who are willing to participate and spread awareness. So I request Mumbai First to share information with them on how they can join the initiatives after the webinars. And I think with this, we can conclude the question and answer session. So thank you very much. Thank you, Lubaina. Thank you, Mr. John, and thank you, Dr. Mehta. And thanks so much for having me. It was a lovely experience. Thank you.
Meesha, thank you for moderating this this whole session for day 2. You've done it excellently well, and I must take this opportunity to compliment you and your efforts. At this point of time, ladies and gentlemen, we had excellent presentations on day 2. Like day 1, we had a very eventful day 1 too. And I must mention the excellent panelists today, Mr. John and Mr. Iyer. You gave a very insightful presentation on the scenario and future plans for the CETP. I must also compliment Dr. Ritesh Vijay, who spoke about the liquid waste management and the various ways that he showed. And I'm really very excited to see the one which is going to come up in Mumbai very soon. I must also thank Lubaina. Lubaina, your presentation of particularly which addressed Mumbai really touched my heart, and I would be calling upon you now on. You're in trouble, as I say, because I will come up to you and would like to work with you in the future and explore the possibilities of how we can work together to bring in awareness, to get, the ears of the right people in the government to help us mitigate and adapt to the problems that you mentioned. Lastly, Meesha, you were the cherry on the cake. Thank you for your relation to the water crisis and the future, along with the climate change scenario. I think that's very, very important. And they say that India is one of the targeted tropical cities once there is a climate crisis. And I believe climate change has already taken place. We are now in the mode of climate crisis, and we in India should be very, very concerned about what are the issues that will erupt due to climate change and climate crisis. So thank you, Meesha. Ladies and gentlemen, thank you. We conclude today's presentations and panel discussions. I must now switch mode to thank people who have played a very important role in this day 2, and starting with our trustee, Mr. Nandan Maluste, who gave us the welcome address and who has been on our executive board. Whilst I thank him for doing that, I must also recognize Mr. Nair, who's our chairman, a very passionate individual who's a corporate, who's an industrialist, and who has given Mumbai First 25 years of his lifespan to develop what Mumbai First is today. I must also thank Mr. Roger Pereira, who has been with us from morning today, listening to all the presentations. And Mr. Roger Pereira is an ad guru, you know, and I mean, people in the business have always heard him and always approach him with a lot of respect and guidance. And also Mr. Ashank Desai, who's the founder of Mastec, also would like to thank him, who's on our executive board. Ladies and gentlemen, this day would not have been that eventful if we did not have a very learned panel like yourself. So I must thank you once again for the excellent presentations each one of you gave. You stuck to your time. Your presentations were lucid, knowledgeable, and it held us all glued to our screens. So thank you once again. I must also thank each and every participant who has been with us from morning. It clearly shows that you all are very interested people who want to know what is the future, what is the current scenario. And I'm also very sure that you also must be contemplating how we can all work together to mitigate and adapt with the situation and crisis that we are going to face. So thank you for being with us. I appreciate your presence. I must also put on record the excellent arrangements made by the Mumbai First team and the Niri team, and I am there, and they are here with us. I must thank them all for making excellent arrangements for this webinar on day 2, as well as day 1, of course. And finally, I must thank the team of the Viscraft people, event managers, who have managed this event on day 2 and of course day 1. Ladies and gentlemen, your feedback forms are in your chat folders. Please do send us your feedback. As I mentioned, we would like to be in touch with you. We would like to know and get your feedback so that it will help us to organize more such events, and maybe in a much better way. If we have made any mistakes down the line, I take this opportunity to apologize to all of you, but with your feedback, we will definitely improve. Ladies and gentlemen, there is one more day, and that's the final day tomorrow, day 3. Don't forget, we have an excellent panel for day 3. That's going to be the cherry on the cake, as I said, and I would advise each one of you to spread the word and be there in time at 2:30 tomorrow for the final day with excellent speakers. One of them is not from India, and he is Mr. Frederick Royan, who's the Vice President of Sustainability and Circular Economy of Atlas for Frost and Sullivan. And there are many more such lovely speakers. So I hope to see you tomorrow at 2:30 sharp. Take care of yourself, be safe, and have a lovely evening. God bless you all. Thank you.
Thank you.